Hello, everyone, and welcome to another space with IONET. This time we have Frodobots on and our Chief Business Development Officer, Tassif, on for this one. How are you doing today, Tassif?
Hey guys, it's good to be here.
Good. As we're having Michael join us as a speaker in just a moment, Tassif, I'll start with you. What exciting updates are there on your side?
Um, yeah, I think it's been a really sort of exciting few weeks here at IONET. Yeah, over the past couple weeks actually. I believe we already talked about, our presence at Token 2049. Obviously, a lot of the leadership team and the business development team were there in person at the conference and across a variety of side events. Had a great time meeting a lot of different builders in the decentralized AI and crypto space. Obviously, a lot of excitement across, at the intersection of crypto and AI. So, and especially a lot of sort of interest in sort of the products that we've been launching and developing here at IONET, particularly around IO intelligence and container as a service and even bare metal on demand. So, yeah, I think the most exciting part about the last couple of weeks has just been seeing all of the customer interest start coming in, having a lot of our partners kind of adopt some of our newer products like IO Intelligence and continuing to scale up their businesses and building things on top of our infrastructure stack.
And speaking of exciting developments on with partners, Michael, we now have you as a speaker. We've been seeing Frodobots all over the place, so I'm sure you have a lot to talk about in terms of updates.
Hey guys, thanks for having me. Yeah, happy to share. Yeah, so actually, in fact, yesterday we just kind of shared this research that we've been actually working for months with a team from UC Berkeley. And in fact, like IONET was really helpful in part of this like research that we did together with them. But essentially, this group from UC Berkeley took a huge data set that is collected, kind of crowdsourced by our community. These are sidewalk robots data basically, and they use that data to essentially train a pretty like state of the art, I would say, navigation model. And so yeah, it's a really cool paper. And yeah, happy to dive in more details. But yeah.
So let's take a step back, Michael. For those that are unfamiliar with Frodobots, how would you describe it?
Yeah, so I would say that the easiest way to say is that we are, I guess, a robotic gaming project. So we started off having this sidewalk robot that you can almost think of it as um, Pokemon Go slash Mario Kart, except that you do it in the real world. So the gaming experience is kind of like you remotely control a robot. It could be your robot, that you control and drive around in your own city, or you can in fact do it halfway across the world. And as you do that, you basically pick up like it's a little bit like a treasure hunt. So you pick up like virtual items, and this could be like Solana NFTs that are geo-tagged to certain locations. And while gamers play this game, we do collect the data, and it turns out this data that we collect has a lot of like robotics AI research utility. So and we have, I would say, a dozen of this like research collaboration with different labs, and the one that just got announced was one of them yesterday with UC Berkeley. And again, a shout out to you guys for providing like really significant compute for these researchers to do the work. Because we have the data, but then without the compute, the researchers can't do anything pretty much.
And where did the idea for this come? What is the pain point that you saw in for the build of Frodobots, and then what was the pain point that Ionet came in to help you solve?
Yeah, so I would say robotics. I would say robotics AI in general. Like basically, if you're trying to create AI models that can control robots, it's a very different has very different bottlenecks compared to say developing AI in the digital realm. So uh, one of the big bottleneck is just the lack of real world data sets. And so obviously, Sour Robots is just one of many robotic type, but that's what we started with. And in the case for sidewalk robot, like they're just nearly zero, robotic data. So traditionally, before we showed up, most of the researchers use, I would say, very classical robotics techniques to basically solve like driving in the real world. But obviously, all the exciting stuff is what they call learning based, right? Using data, scale compute, so that you can train up a very generalizable AI model to, let's say, drive a sidewalk robot autonomously. And so ours is, I guess, the first attempt to really crowdsource this. And the UC Berkeley guys kind of stated in their paper that the data set that we released last year was already 25 times larger than any other data set out there, and we're actually about to drop a way bigger data set again, like with IONet cell. So yeah, so I would say, like, I mean, having the data is one part of it, but once you have the data, then a very good problem is that do you have to compute to actually make use of the data? And so I mean, just to put things into context, the data set that we released last year was about 2,000 hours of sidewalk robot data that's collected in a dozen cities around the world. And it's so that ends up being around, say, 2 terabytes, right? Mostly video, but also a bunch of other like other sensor information, as well as literally what the gamers are doing. I guess we call those action labels. In any case, once you have this 2 terabyte of data, you probably basically need some GPU, right? If you want to build let's say, train up these days they call it a VLA model, so visual language action. And it turns out, I mean, you really need non-trivial compute. So I think in the case for this particular research, I think the VLA model actually hasn't been announced fully yet, but I think we'll do it in the coming weeks. But in that case, it turns out you need roughly one full box of H100. So that's like 8 H100. So really non-trivial compute. And it takes around 1 week or more for one training run. So, and that's only with, let's say, 2,000 hours of data set. And like I said, we're about to drop a pretty big one together with this same team from UC Berkeley. So I think as we scale this data using crypto incentives and DeepIn, I hope or I imagine that the scale of this data will maybe 100x or even 1000x. So you're not talking about terabytes, you're talking about petabytes. And I would say the compute need basically scale kind of linearly with those data. So you scale the data like becomes petabyte, you probably need 1000 times that box of to compute. So it's really non-trivial compute if you want to do things like really move the needle for robotics. And so yeah, I think it's you just need a lot of compute, I think, going forward. And yeah, so I think it's a very good problem to have. I mean, in the past, like literally we don't even have the data to play with. Now we're starting to use DeepIn to scale that up, but correspondingly, we need a lot of compute to match those data in order to create interesting AI models.
Definitely a good problem to have. Tasa, bringing you in on this, what are the unique challenges and benefits that you see from the IO side on this? I hear all the time about need for more compute. What specifically excites you about what Frodobots is doing and how IO is supporting?
Yeah, absolutely. I think there's a ton of like opportunities here between IONet and Frodobots, right? And it's because I think we both kind of work on sort of mutually synergistic like areas of innovation and development, with like IONet bringing in the compute and Frodobots obviously bringing in sort of very rich video and robotics data in a decentralized way that's typically kind of like hard to sort of aggregate and get access to at the scale that at least Frodobots is planning to get to for these data sets. I think in terms of opportunities, right? Like I think, yeah, as Michael mentioned, as the amount of these, the size of these data sets and sort of like the content of them grow larger and richer, the amount of compute that's actually needed to process all that and kind of convert that into, sort of like AI models or video models that are usable in a variety of different sort of like industries and use cases. Just the compute needed for that kind of grows exponentially, right? So yeah, with Frodobots like data sets, they have like a lot of sort of rich information kind of around like multimodal video, robotics, GPS data, audio, things like that. And we're kind of talking about like the scale of like petabytes of data, right? Like when you kind of pull all of it together, especially with kind of the scale of where Frodobots is trying to go up for. So I think IONET kind of coming in as as the need for the compute scales, this IONET coming in with our 80-90% like cheaper compute compared to sort of like larger scale hyperscalers. It really sort of creates this way for teams, whether they're sort of, like research labs or universities or anyone else, who can come in, leverage the compute from our side, leverage the data from Frodobots, and kind of really iterate on, like large vision like transformers, like multimodal models, diffusion-based planners, things like that, and kind of really innovate along those lines a lot easier, right? I think I also anticipate like the fact that both IONET and Frodobots are kind of coming at both angles of compute and data in a very sort of decentralized, deep-in manner. Um, it's very likely that kind of our sort of decentralized network and kind of global footprint can really start to match where these robots kind of really are, and kind of really kind of cut down the amount of like time and latency for these data sets to be uploaded to like the nearest like compute and storage nodes and kind of processed pretty quickly and turned into actionable like insights and models that are used in the real world very quickly. So kind of making that process for iteration really fast, I think will be super key. And I think there's definitely with any kind of new model and decentralized physical infrastructure network, there's always kind of challenges when it comes to growth and scalability. I think especially when we're talking about the size of the data sets that Frodobots is working with, obviously kind of bottlenecks on like bandwidth and data storage and things like that will have to be kind of figured out as the scale grows. But I think the opportunity itself with the data that's being collected and once it's processed, what it can be turned into is so massive that I think a lot of those kind of challenges along the way will be figured out.
And Michael, bringing it back to you, how do you envision this collaboration shaping the future of embodied AI, particularly in robotics data and AI models accessible to researchers and industries globally?
Yeah, so kind of like double tapping on like what Tausif mentioned. So I think he mentioned something about latency just now. So what I was describing earlier on was actually kind of the pre-training phase, right? So like one giant data set and then you train a big model. So that's one phase of it. But let's say even after you create let's say a pretty good model, they call it, I guess, embodied AI model or VLA models, you still need to run it at inference, right? And so I think like I'm glad like Tausif mentioned about this. So it's during inference you also want to run those basically train models, but do it with very low latency ideally, so that in effect you have kind of these embodied AI models that's remotely controlling this let's say sidewalk robots, right? So that they can still actually navigate in the real world with very low latency. So I think compute will be required on both. I guess especially I think now we're at the stage where maybe more of the focus is still just maybe on the the training phase, I guess. But I think once we maybe in the coming years, as we start to have a lot more data, we start to get to models that is becoming very performant, then you're talking about maybe a shift towards like maybe more compute that's done at inference. And I should say also like robotics data in general, I'll consider that there are actually three types of robotics data. So what we've actually started off with and we'll continue to do is basically teleoperation data, meaning data where you have a human controlling a robot, and then so in our case it's a game, it's a human gamers controlling the robots, and you collect the data in the real world. So that's one type of data. But there are actually two other types of data that I would say also very important as well. So the second would be like simulation. And these days you have world models as well. And so that's the second type. And then the third type is just like straight up video data or just YouTube video. And I would say all three types of robotics data have their bottlenecks, but ultimately you still need a lot of compute. Whether you're, you're collecting real world data, and then you train a model on it, or you do simulation or world models. Obviously, you need a lot of GPUs. I would say especially for world models, I think that's the so-called cool kid on the block. I think there's a lot of very cool research that's ongoing, trying to create world models that reflect the physical world. And I think there's a lot of interest in the robotics world doing this sort of research. And from what I can see, the compute requirement is, especially for world models, is also tremendous. It's maybe potentially even more than if you train a big VLA model using teleoperation data. So so I think world models will also be kind of really needed. And then also video data as well. Like if you just like scrape a bunch of YouTube video, let's say specific to self-driving, you will still end up needing a lot of compute. So I think everywhere you go, regardless of the types of data, like any of those three, you need tremendous compute. And you also want, I guess, now if you have the data and the compute, then you really want to really work with really cracked researchers who know what to do when given those amount of compute and data. And I would argue actually that's another very big bottleneck. There are really not that many people who know what to do when given that kind of like that scale of problem. I think that's where robotics like research are today. I wish there are a lot more crack researchers, but the fact is that we're actually quite bottleneck there as well. Yeah.
And Tassif, let me bring it over to you. How does this partnership fit into the vision of IONET beyond just providing low latency and uh, compute power? How does robotics fit into the ultimate vision of decentralized AI?
Absolutely. I think in terms of kind of where it fits into the vision of decentralized AI, I think the way sort of, Frodobots is going about it is, very unique, and I think kind of fits very neatly into sort of the ethos of how, researchers in decentralized AI and sort of at the intersection of crypto and AI are really thinking about decentralizing different parts of the tech stack, right? So I think previously I've talked about us at IONET kind of decentralizing the foundational part of the AI tech stack with the compute aspect of it and sort of aggregating GPUs across a variety of different sources. I think with Frodobots, the way they're going about collecting these video data sets through these robots in a decentralized manner is fairly ingenious, right? And kind of is a great way to aggregate a tremendous amount of data that's typically a lot harder to do in the real world and kind of truly incentivize in any other way. Sort of being able to kind of pull that together in this format in a decentralized way kind of really enables people in the decentralized AI world to have a dependable source of real world video model data or video data to put into their world models or video models or VLAs, things like that, without any dependency on centralized data collectors or providers or issues with like privacy and things like that, right? So I think in the way Frodobots is going about doing it, this really kind of fits in with the overall ethos of decentralized AI and making sure that every part of the AI tech stack has robust decentralized alternatives for researchers in the space to leverage and continue building for the future.
Speaking on the issue of future, Michael, looking 5, 10 years ahead, which is a lifetime in our space, what do you hope to achieve both at Frodobots and through this partnership?
Yeah, I mean, I think um yeah, I don't know. So for robots, that's how we started as a project. But actually, um, we, there's a big, I would say, a bigger project called Beat Robot that we kind of like partner with the folks from Protocol Labs to create, which is kind of like a network of subnets that will um uh, basically gather resources to really advance embodied AI. So my hope is that really through Bit Robot Network, of which Frodobots is going to be a very active participant, but there really should be other participants, hopefully. So it will become a very vibrant ecosystem. And the idea there is that there will be participants such as like, could be other robotics lab, could be other Web3 projects that bring in unique data sets or like resources like compute, right? So IONET obviously will be definitely one of the key ones, I think. And because the whole stack, you require many different type of resources. You don't just need so-called compute, right? You need um, perhaps in our case, like teleoperation data, you actually need a lot of manual labor if you think about it. Um, these human gamers, they are putting in hours, right? So I think the ideal case is that we give them crypto incentives to incentivize them to keep basically putting in the hours, right? We also need to do the deep thing, meaning we basically create like new robotics embodiments. So Sawa robots is our first, stuff. But we're actually starting to do some work on humanoids. We actually have this game called UFB, Ultimate Fighting Bots, which is just think of it as like you down into a humanoid and you fight against each other. So Fight Club for humanoids, right? So, but it's the same thesis as what with like with the Sour robot. Basically, gamers have fun playing the game while the robots generate data that could be hopefully useful for research. So my hope is that in the next 5 years, there will be a lot more of such endeavor, right? Not just Sour robots, but other types of robots. Could be drones, could be surgical robots, could be humanoids, and also taking on very different tasks. So it could be not just urban navigation. It could also be let's say getting a humanoid to fry an egg, right? So that could be a very significant challenge for robotics. And so, and hopefully, like with that, then we have a very vibrant ecosystem of different data sets, provider, different compute providers, and then ultimately a big fleet of real physical robots that these researchers can test the models on. And so yeah, so I think it's a very ambitious project for BitRobot. But I think crypto it's has a very unique place here. Um, I think if this is done well, this is something that probably even the big labs of the world, like the deep minds of the world, won't be able to do some parts of this. I don't think the Nvidia, the Microsoft, the Googles of the world are going to deploy cyber robots in hundreds or thousands of cities around the world. Uh, the only way to get there is using, in my view, do something like BP, right, where you truly cross-source that deployment. Um, so I think yeah, so that's my hope. Yeah.
And let me ask as we're closing out, Michael, let's say I'm excited about this project. I want to participate. I want to learn more about it. What are the next steps that I take?
Yeah, I would say, I mean, the easiest way is to play the game. Um, or you can just buy one of our Cyber robot, which is kind of like a toy, right? It's like $200. And these are very well tested in different cities. It's been tested in snow environment or through storm and all that. So buy it and try it out. I think that's the easiest way. Um, and and start contributing data or start contributing like starting to do the deepin thing. And of course follow us on the various like Twitter handles that we have. So we're on Frodobots, or follow us on Beat Robot as well, Free Robot Network. We have a ton of announcements coming out, and some of these, of course, like with you guys. But yeah, I mean, I think yeah, this year will be pretty exciting. Um,
Great, thank you. And then Tassif, I know that the IO team is going to be at the AI Dev Conference in San Francisco. Are there any announcements you want to plug in?
Yeah, yeah, absolutely. So we'll be at the AI DevCon in San Francisco, I believe, in a couple weeks. We'll also be at the Economist AI Compute Conference in Copenhagen next week. So we'll have our head of research from the Adage Foundation presenting about decentralized AI and our research as well. So we'll be there kind of along with a lot of other sort of like key Web2 AI figures. And then, yeah, going into June, we'll also be building up our presence for Super AI in Singapore. So a lot of exciting touch points ahead for us.
Great. Well, thank you both for this. And as always, thank you to our listeners. And we look forward to having you back on to talk about where things have progressed quite soon in the future.
All right. Yeah. Thanks for having me.
Awesome. Thank you. Take care.